So I will take some questions on problem set 17 after the lab, especially if you've gotten a good jump on it and you're like, oh, well, I have one question I can't do. There is the one question that talks about boiling water, but that's not the water in the calorimeter. So remember, sometimes we have to boil water to get the metal to a certain temperature because we can't put metal in the microwave. So that's just our way of getting something to a warm temperature. So when you get back to the lab, you'll read the intro because the intro has a lot of good information that's really helpful in answering those lab questions. So if you ask me a question and you're like, I don't know where to go from here, I'm probably going to revert you back to the intro for the moment so that you can review what you need to. We have most of our coffee cup calorimeters are double walled. Why do we want them to be double walled? Okay, so like double insulation. What you'll notice is some of them are fancy. Okay, so they actually have a double wall on the inside. There's actually like a 2-line cuts in here, but it doesn't look like it, so it's fine. But you notice this cup is this tall, but it's actually kind of narrow. Shallow because it's just because the cup inside is smaller. What you'll do whenever you take the sheath off the thermometer, whoever you're talking to, what we'll do is upon doing the lab, upon actually starting the experiment, you will have your lid, which is like kind of a foam insulation as well. You'll stick your thermometer through, okay? But you don't want too much of it to get through because you need to be able to see the little red line. If not, you won't know the initial temperature nor the final or whatnot, right? So you might have to kind of go in and out if you need to a little bit to see if it's dropping or rising. But do not stick this all the way through. Do not poke a hole in the bottom of my styrofoam cup, okay? Because this is exactly how many I have what I need. So this actually is too tall. It's already hitting the bottom, so you'll start to scooch down a bit more. And upon, putting in things in here, you'll just do a little swirl or a light twirl of the thermometer so that things are mixing, because if it's not mixing together, you may get incorrect data, okay? So that's all I need to show you here. And then in the lab itself, scooch back up here. In the lab itself, it has just a couple of data points. So your data table will be kind of short. But that's your background reading right here. There's your background equation. Like, you don't know that one. I know you do. It tells you initially to heat up 125 mils of water to about 50 degrees Celsius. On the hot plate, that's about a 5, but don't crank it to 5, right? It starts off cool. We're going to go to about a 1 on the reading of the hot plate will be about 10 degrees. Then a 2 will be 20, a 3 will be 30, a 4 will be 50, a 5 will be 50. So the idea is that you're slowly heating it up. If you go too hot, your lab's going to take longer because it's going to take a while to heat it up. So when you hit about 50, you're good, okay? And then you're taking that 125 mils. It's going to be a little warm, but not so warm you can't hold the beaker, okay? So don't try to use the beaker tongs because I don't imagine you're very good at pouring out water with beaker tongs. I'm not very good. So the 125 will go down to 75 mils of that heated water. You'll put that in a graduated cylinder. Of course, what size graduated cylinder would you be using there? 100, because if not, you're not going to be able to get 75. And now it's going to be a very snappy process, because the moment you take the hot water off the hot plate, what's it starting to do? Cool down, and then immediately you're losing heat. And you're going to think it was one thing, and then it's going to be something else, because your heat transfer happens very quickly, okay? So that's about the only thing I really need to tell you there. When you start to grab the ice cubes, it does specify 2 to 3 ice cubes at a time. So when you grab those, put those in there. And then ice should be in there at all times. So if you peek, you do have to open the lid and peek in there to make sure there's still ice. Because once the ice stops melting, meaning there's still ice there, it's not going to melt, you're done. Okay? Groups of 3, labs, go. I might have one group of 2. 26 of us this morning. You have about 10, oh, you need goggles. 10, 9, get to your lab station. 8, it's okay if we have a couple groups of 2. 7, 6, get to your lab station. 3, get on Alright, let me get our satisfied. Now I've got a field from last week and this little crowd over here. So get to the last station you selected, and I'm going to move you over now. Okay, so I have 1, 2, 3. Right, excuse me, left. Okay, can one of you listen over here on the floor? That's fine. Here's your problem. Alright, push the left of it, guys, and get rolling. You should have goggles on. You don't have the only hazard is 60-degree hot water. So do not need a hot water heater if you have no close use storage. Read the intro.